Good afternoon, and thank you for joining SPEC Innovations webinar, How to Write Requirements. My name is Elizabeth Steiner, and I will be your moderator. Today, we're kicking off a new webinar series, How to MBSE. We'll be starting with requirements development all the way to verification and validation. You can join us for the whole journey or choose the webinars that best fit your needs and interests. Before we get started, let's go over some quick housekeeping. During the presentation, feel free to send us your questions so we have them ready for the question and answer session. Alternatively, you can ask us questions in our LinkedIn user group or through Twitter using the handle @Innoslate. The webinar is being recorded and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. Dr. Dam is the president and founder of SPEC Innovations. He's been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an Expert Systems Engineering Professional certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group or send him an email to steven.dam@specinnovations.com. I'll go ahead and give the controls over to Dr. Dam and we can get started.
Sorry, I realized I was showing the wrong screen. So it's typical of these kinds of things. So when we start off here with, we look at the whole life cycle, and requirements are an important facet of actually the entire life cycle. If you think about it, documentation, oftentimes where you start gathering requirements that are external. Many of the systems I work on, I start at the high level architecture of the systems really, and capturing things like policies, regulations, things that are rules that cause you to do certain things. You might consider them constraints, but they're really a type of requirement when you think about it. Once I have that and I've gathered other information like what are the user needs and some of those kinds of things from the users, I will do a requirements analysis. And then we'll do derivation of more requirements at the lower levels as we work through that. Simultaneously, we're often doing functional analysis to try to understand what the functional requirements are. Sometimes I'll even have to do that earlier in the life cycle, because I don't have a lot of information, or the user doesn't know exactly what they need, or how we going to even operate the system. So you do a lot of that kind of analysis so you can derive those functional requirements, which are essential for things like the agile software process, things like that, because it starts with functional requirements. And then of course we're going to verify those requirements that are at the design level of verification, and validate the operational level requirements as we do that part of the test and evaluation process. As you see, requirements are part of all of this. It's not like they're separate. And of course, you can't forget about actual work results. Let's say operational analysis and risk analysis, because risk is a key part of as we go through it all. And then of course, operations analysis. Make sure you can apply it during the operation time. Again, those might be operational constraints. So again, we're going to talk about all those aspects of requirements as we go into it today. So particularly, one of the things that we found is it's always good to have your requirements analysis process. We use this to help guide us in understanding how to do better requirements analysis, and kind of force us to think about the key things we might want to worry about as we're doing requirements analysis. So again, we're taking information from lots of different places, and if you're going through in a cycle, you may have change requests even that you're getting, or there's an external database you need to interface with that has sets of requirements. So there may be lots of sources for requirements. And again, you oftentimes, again, what we're doing is decomposition. We're trying to break them down into so they're really understandable. So at the root level, at the leaf level, we have a clear statement of what the requirement is. And oftentimes, as you're going through that process, you're going to identify critical issues. and problems, and that might cause you to spin off and do some trade studies on the requirements themselves. You know, a lot of people think about trade studies in terms of the physical hardware or software, things like that, but you also do it here, because there are all kinds of trades you can make, and particularly early in the process, to maybe reduce the costs or reduce the schedule or the problem as well. So those are all things you want to try to do. And then, of course, you want to resolve those with your customer. We always want to make sure we keep our customer in the loop. You know, expectation management is a key part of systems engineering, and you have to get very good at that. So communicating with your customer, making sure they're on board, and the other stakeholders. I say customer might be your direct funder, but that may not be all the stakeholders you really need to keep informed and keep in the loop. So that's, again, a reminder to do that. Then the next decision diamond down there says statement verifiable. I say that because that's one of the most important factors. It's not the only quality factor we look at, but it is clearly one of the most important, because frankly, if you can't verify the requirement, it's a useless requirement because you don't know you met it or not, right? So that's obviously one of those key things. But also do that to remind us that, and of course, making sure you're going to coordinate those changes as you go through it. But remember that out of this, a lot of what you're looking for, and the reason we like the V diagram, is reminding us that we're supposed to be doing things on the left side of the V for the right side of the V. So that's the preliminary test requirements go out that way. Or in fact, what we're pushing towards is actually go further than that and start building your test suites and your test cases as well. And we think that's best practice today. So in other words, as I'm coming down that V, I'm thinking about what are the higher level operational requirements. I need to think about how I'm going to validate those requirements on the other side of the V. So that's, you know, that's if we start doing more of that, we're going to find that the back half of the V goes very fast. So we spend a little more time on the front end, but a lot less time on the back end, and so you end up getting their product out to your customers much quicker. And so also want to think about traceability. Of course, that's a key part of requirements. You know, where do they go? How do you tie them to things? So maybe it's to the functional elements, which we call actions, or the physical elements, which we call assets, or maybe it's metrics. Maybe it's identifying key metrics for the system, and so we call those measures. So again, that's what we work with. And of course, in this process, you're always looking for identifying risks. You know, you hear a lot about risk management. Risk management's useless if nobody's identified the risks. So each of our processes actually has a specific step just to make sure we remember to identify risks as we go. And again, this doesn't necessarily mean this is linear, by the way. This could be a very iterative process you're doing all through these different cycles. And of course, you're repeating it as you go down the V, in fact, at different levels of decomposition. And then, of course, make sure you review with your customer those statements and risks and update your knowledge base. And of course, hopefully you're doing this in a knowledge-based tool, because today, the requirements we have are so many, it can be overwhelming at times. Many major programs have tens of thousands, if not hundreds of thousands of requirements. And you can't manage those in an Excel spreadsheet. You can't manage those in a simple access database. You need something that really can help you work with the information and curate that information and communicate that information. So, you know, that's what we're looking to do with this knowledge base, building these knowledge bases. So what we're going to talk about is we're going to gather requirements. We're going to talk about baselining and change management. We're going to talk a little about using artificial intelligence, and a particular branch of artificial intelligence called natural language processing to manage the quality of the requirements. We're going to checking requirements for your risks, you know, how to add risks to this as well, and relationships. How do you do traceability, verifiabilities? You know, is it satisfied by? And then, of course, reports and matrices. And of course, we're going to talk a little bit about creating verification requirements. There's two camps on that. Some people say, well, just make your requirement verifiable. Great. But I found that often you want to create separate verification requirements because the way you're going to verify the requirements have an impact on it. So it's a little different kind of thing. So so you may decide that you want to separate those. And classically, we always did that. If you go back in the 60s and 70s when you were doing a specification, Section 3 was the requirements, and Section 4 was the verification requirements. They were separated out for that very reason. So about baselining requirements. So, you know, once you have them defined, you have them in a form that you're ready to go. You want to put it under some kind of configuration control because you don't want requirements changing too rapidly. You want to watch out for requirements creep. Okay, that's always a big problem. You know, we have this problem every time we're building our software. We have to be very careful of, well, we got to have that feature now. No, that's not part of the plan. We're going to have to put that in later. We schedule that for a later release because that's what you have to do. You cannot do all the requirements, everything everybody wants at once. It's just not possible. So you have to do that. And so you want to baseline those requirements and work with them. And I think there's an actual link here. And so this is a lot more information about baselining, and so you can take a look at that if you like from Lou Wheatcraft. So why do I need to baseline my requirements? So that link will be available in the when we pass out the slides. So baselining requirements. So looking at that, you want to make sure you have proper configuration control. You're creating reports to send to the stakeholders. In Innoslate and in many other tools, they use some kind of indicator that you have baselined a particular requirement. And we use a blue bar to indicate that. It's normally a yellow or orange bar, depending on what your browser looks like. And so that vertical bar shows you that it hasn't changed from that last. If it's blue, it says it hasn't changed since the last baseline. So again, you can, if you're a reviewer in Innoslate, you can add comments, and that's the way we recommend interacting with people who are doing like a requirements review. So you go through that process of a model-based review. You can have them come in, work within the tool as a reviewer, they add comments, and then you can do a comment adjudication right there with them and see it. And then there's quite a nice comment report that's available as well from the tool. So you can kind of track all that and show how you've met all the comments. So one thing about requirements analysis is that there's kind of two approaches people take to it. And I tend to use both. It's not an or, it's an and. We do both. And so I think you want to look at this as two opportunities to look at. So let's look at the first one, heuristics. So heuristics are basically taking rules of thumb, okay, best practices, and applying them to different to the requirement and saying, is this really a high quality requirement? So the difference between one of the things we differentiate in Innoslate is between statements and requirements. Statements are meant for contextual information. You're capturing that as things that are things, and it can be things like goals as well, can be a statement. It doesn't have that, so that's kind of a higher level kind of thing. It's not something I care about to really evaluate from the perspective of as a requirement I'm going to allocate. So the requirements, though, are very specific and they're very structured, and most people will say that shall must be in there to make sure that you have it contractually binding. Most people will feel that you should be able to use these other words: will, must, should, must, those kinds of things. And again, if you want to do those, that's fine. If you want to consider those as part of what is an appropriate requirement, that's really up to you and your organization, what you decide to do. But you see, what you're looking for is a very simple statement. The system, in this case, the pump, shall weigh no more than 1.2 kilograms. Okay, very strong requirement. Now that's really a performance requirement, right? Your system, your pump in this case, can't weigh more than a certain amount. It doesn't tell you what it's going to do, so that's not a functional requirement, but it's a good, very good performance requirement. So the ones we use right now in the tool as our primary metrics are clear, complete, correct, consistent, design, feasible, traceable, and verifiable. These are ones we've used for many, many years. I understand there's a new set from NCOSE. I believe these encompass most of those, if not all of them, but we're actually in the process of evaluating that new set and seeing how they fit. But for now, this is a pretty good simple set, and it's easy to understand. So the first one's clear. Is it unambiguous? It's not confusing. It's not hard for somebody to understand what it is you're trying to express. And of course, is it complete? Does it express a whole idea? Does it really, is it under, that comprehensive kind of nature of it? Now, correct is it basically legal? Can you legally do this requirement? Again, that's a tough one to evaluate through heuristics. That requires some knowledge of how the system's going to be used, where it's going to be used, those kinds of things. Consistent, not in conflict with other requirements. That's important. You don't want requirements contradicting each other. You can't say the pump has to weigh 1.2 kilograms and some other part of the spec it says that the pump has to weigh 1.4 kilograms, so it's or less, so you don't want to add those kind of inconsistencies in the specification, and that's a pretty glaring one. That would be one probably picked up pretty easily, but there are other ones that are much more subtle that'd be very difficult to see otherwise. Design, it doesn't impose a specific design solution. It's one of the biggest problems in requirements development. A lot of people will write a requirement because they know what they really want, and they really want that iPhone. So the requirement specifies all the different features of the iPhone. It doesn't just dealing with the basic functional need of communications and things like that. So that's what you're watching for that. You want to keep that independent, because otherwise you're not giving your design engineers enough flexibility to come up with a better solution. So that's another thing. As systems engineers, our job isn't to do the design engineering. Our job is to give them the specification that they need so that they can come up with a good design that's going to fit with the rest of the system components and meet the user needs. Okay, so again, we got to be very careful how we do that. Feasible, is it possible? Within the technology cost schedule you have, again, that's kind of a judgment call. That's a tough one to quantify. And then traceable, is it unique? Can you track it between things? And most of the time, the answer to that's probably yes. Again, it's part of that. The rest of this being done properly, you can do that. And then finally, verifiable. Can you prove it within, again, realistic cost of schedule parameters constraints? So you do have those, and to meet the requirement. So again, all these now, the Innoslate's artificial intelligence software, right? And again, we use NLP for that. We do clear, complete, consistent, design, traceable, verifiable. The two we can't do automatically are correct. Is it legal? And feasible. Is it possible? Okay. We do think those require human intelligence. So again, any kind of quality factors, really you're looking for the tools to help you with those quality factors, you're not really asking the tool to think for you, I hope, because it won't. Okay. Okay, so heuristics. So again, more heuristics about it. This is sort of the don't part. Don't use ambiguous language. Don't use bulleted lists. Use numbered lists instead. Again, actually what you should do rather than have a list is each one of the items on the list becomes its own requirement. That's something you gotta be really careful about, whether you just give somebody a list or do that. Now I will say sometimes a numbered list is better. Very often in software requirements, we find that giving them a list, particularly as something's affecting a particular component, it's sometimes easier for the software developers to use it as a checklist to go through and check off and see things. So again, this is not, none of these things are the be all and end all. You have to use your judgment, your experience to determine when to use what. Jargon and acronyms, again, in general, that's bad practice, but let's face it, we do it all the time. If it's common within your industry, a common acronym, everybody understands it, and it's communicating well to your stakeholders, fine. Like DoD, right? Department of Defense. Almost everybody, certainly everybody within DoD knows what that means. Anyway, so don't use escape clauses, and that's a common one that happens. It's very ambiguous. It's very difficult to quantify. Long rambling sentences, again, it should be short sentences, clear sentence, single sentence, no ands, no construction, all that kind of thing. Oh, and don't use vague terms. That's a big one. User friendly, one of my favorites. See it all the time. Right, so I mean, if you get one like that, right, what you need to do as a system engineer, you may be given that from your customer. We want this to be user friendly, so you have to go get a definition of what they mean by user friendly. You have to then derive a more detailed requirement from that. So that's not the requirement. That's going to be more of a statement level kind of item, and then you would take it the next level. May, should, oughts, again. Shoulds are kind of one of those. In may, ought, again, all these things could be used. It's not best practice, but again, as long as you keep it consistent, you're probably fine. And the wishful thinking, 100% reliable. There's no such thing. Okay, 99.99, yeah, 99.9999, yes, perhaps even. But you start getting beyond that, and your feasibility goes right out the window. Your costs go to the ceiling. Your schedule goes out to the right. So all bad. So again, we want to work on keeping those realistic. So check the quality of your requirements automatically. Again, this is the thing we do automatically for you. You see an example here showing you on the sidebar. When you click on the requirement itself in the tool, you see that's highlighted and has a little green check mark on it and a little red knot, so that if you're making a change to it, you could cancel that, or you could accept the change. By the way, the default is accepting any changes. And so you see your quality score over here is rolled up as 38%. So it's taking all those items that we just talked about, the clear, complete, consistent, correct, design, feasible, traceable, verifiable. It's adding those yeses and nos up to give you the score. Okay, so it's very simple. There's no weighting, by the way, of it. Again, that's probably some people often ask about weighting. I'm not sure the value of doing that, but again, if that's something important to you, you will have to kind of manually weight it. Anyway, so the clear, you can see the suggestion underneath it. It came in as a no, and it gives you, then the NLP gives us a thing was passive voice was shipped. So again, that makes it less clear. Again, you want to use active voice whenever you're writing something like this. That's hard for us as engineers. We tend to write in passive voice, so it takes a little bit of training for yourself to turn things into active voice. Complete, again, see all the things that are missing that make it kind of like, wow, it's got all kinds of problems to it potentially. So in looking at that. Okay, so yeah, there's some other issues with that particular one. So again, you can see you go through and look at these and agree or disagree. By the way, you can say no, I think that's clear enough, boom, and go. But again, that's you having done that as an analyst and saying you're comfortable with the way it's written. Okay, intelligence views. So there are some other heuristics that are available to you. Also using the NLP technology. So this is another thing we provide for you. There's 68 of these, so it's a lot more stuff. There's some global ones that are specific, particularly would be applied to requirements. It's like duplicate names or similar names and things like that. Again, that just kind of loses clarity. So it's a number of things like that in the global heuristics. And then here's some of the ones that are specific for requirements. There's 9 specifically for that. So again, looking at that particular leaf level shall is something we think again is best practice. That's provided for that. And then of course you can set those. You can adjust them as you want to as errors, warnings, or ignore them. And if you do decide you want to fix something, there's a fix button, and it'll sometimes help. Often help you in either helping you in terms of telling you what to do, or actually even do it for you. It's like when you have 2 names of the same type in the global, the fix will be a merge. I want to merge the 2 entities together into one, and that does a very nice job, by the way, of merging those together. So I think things like that are very helpful to you. By the way, these heuristics came to us from some research done at Naval Postgraduate School, Dr. Kristen Gianmarco's research in particular. And so this is something we made up. It is from, and we try to do that a lot in our tool, is apply research from different people who are doing that. So if you're actively doing any research in this area and you see some things that we are missing, please offer them up for us. We're happy to see if we can incorporate them into the tool. So documents management. So one of the things is, as you build your requirements, you may have a set of requirements, or in fact, you might have quite a number of documents you're managing and working from. So we have that ability in documents view, and you can characterize the different types of documents. You can also create your reports and things like that. So as you're doing your requirements, you might have to do a requirements report for that as well. You can add those in and provide that as in addition to your specifications. But there's also places for your test planning, since that test planning should be starting as you're developing your requirements. So a lot of other things you'll be working with. Of course, the project management plan as well. We have all of these available, and of course you can add your own types. So working with that, and the other thing you can do is use the cross-project feature. Okay, so this means that I can use requirements from other places or information from other places, and then you'll see that redaction thing to show up there, because since you can have in other projects different people be able to view the information, maybe some people you don't want to see the information. So that's there for you. You may have access to both, but you would click in there and then be able to see the information. But it would remind you that if somebody's looking over your shoulder that shouldn't have access to that information, they wouldn't see it. So that's why that's there as a kind of safety feature. We also, a lot of people say, well, gee, your baseline LML schema doesn't capture all the information we need. Yes, it was designed to be sort of an 80% solution. It was never designed to be a 100% solution, because that would make it too complicated, and it would make it too specific for a particular domain. Usually is where you go down that road. So we provide that schema editor so you can extend it and add attributes, add relationships, add things to any class. Labels. Oftentimes it's just I want to organize the information a little differently. I have a different type of thing. So we usually use labels for organizing other types of requirements and things like that. So So try, see if you try to avoid modifying the schema if you can. We suggest minimizing additions here, but when you find you need to, do it. I mean, it's not a big deal. It's very easy to do. It's a little too easy to do in some cases. It is an owner privilege of the project, so only project owners. And by the way, if you decide organizationally you want to be able to make those schema changes across your entire organization, that can be done through the administrative dashboard in the organization level. Labels for sorting and filtering. Again, I mentioned I use labels a lot for that purpose, and making sure that I can have the right set of them. And it's nice because as you have the labels, it will then show you the numbers of the things in other places and how many you have of what type. You can filter it and see just what you want to see in the view for that purpose. Oh, by the way, also one other thing about labels I meant to say is search. You can search by label as well, so that can help you with your search, and particularly in database view and some of the other views where you have multiple ways to search for information. That's another way to help you sort and filter what you need. Creating reports. So we do have a lot of different reports available. Every view you're in has a little report button at the top in the little toolbar there. You can see that report tab, and that brings up this little modal that comes up and gives me a list of what reports are available. So we have, RVTMs, requirements, verification, traceability matrices, the VCRM, all these other things that are in there that are available right out of the box with it. So that can be helpful. Another thing I find is that's very good, though, is that you can use database view to create the kind of tables and things like that. They're live, like an RVTM here. Yeah, you can see I'm doing basically the same thing here in database view. So I've got my requirement in my first part of it with the label of it, and then the verified by that's the relationship going to the test cases that I'm associating with it. So this gives me here's how I'm testing those things. And so and all you have to do is once you set up that query the way you want to, you can then hit a save query. In the save queries place, there's a button at the top of it. You're not seeing it here because I had to scroll down to get the verification requirements matrix, which is what this is. And you can save it then, and again, you save it for yourself or save it to the project if you're the project owner. Again, that's very helpful for other people to be able to see the same views you want to see. You can even set that up in a way that you can provide instructions for reviewers to take a look and see at the information as well. So lots of different ways. We're trying to get away from outputting to office products until they're really finals. We really are trying to get to what we call model-based reviews. We've actually been doing those for about 6 years now. We've had a variety of people using the tool to do this. It's very effective. It can be done on major milestone reviews even. So this is not a weak kind of review technique. It keeps us from having to go spend all this time and money printing and creating all these extra documents. You're building your documents in Innoslate if you're doing it well, and so you can use it to actually guide people through that whole process. And I think you'll find that it's a very powerful capability. Okay, so that's kind of heuristics. Functional analysis. So functional analysis is something a lot of people say, well, wait a minute, what's that have to do with requirements? I'm doing functional analysis. Well, why are you doing functional analysis? You're doing functional analysis to derive the functional requirements. That's the primary purpose. And if you add simulation to that, you can also start deriving the performance requirements. So again, those are things you want to do, particularly this is maybe for the lower level or maybe at the very high level. Like I say, very often when I'm doing an architecture study, I had an architecture study where they told me gave us a very high level requirement. It was just to make something Joint Vision 2010 compliant. And I went in there and looked at the topic area in Joint Vision 2010. It was one sentence in there. And so that wasn't much of a requirements deck. So we went through and said, well, okay, so what are the systems we're looking at and how are they being used today? And then use that to help us project how to go forward. We did that by building functional models. So you can create that functional model and use it to help you understand where you want to go with what you're doing. So this is an example of a functional model for a medical system that we were working on. And so you could see that you're just following the process. You know, somebody arrives at the clinic, they're answering a questionnaire, they take a standard test, on and on. So you just step one, step two. It's fairly easy to start building these models. You notice there's a lot of parallel because there are often multiple people or multiple actors or multiple assets, is how we call them, in operation. And those are the actor branch assets. And so you can actually apply those and see who is doing each of these actions. And in fact, if you use that, it will automatically allocate those actions to the actor or the asset. And so so that's a good way to look at it. So this analysis is really good because you can then now simulate this to start looking at your performance side of things as well. We'll talk about that more in a second. Also, as you're going through this process, you can use the diagrams for risk to capture your risks as you go. And again, that can also be used during the in your heuristics phase as you're going through, and you should be starting to identify risks there as well. So you might want to capture those and build up your risk matrix in parallel with this other development. And of course, performing runs. By the way, we do have a process for this functional analysis. I'm not showing it here. It's in the books. So you can see a little bit more detail how we approach functional analysis. Very similar to what we did for requirements analysis. I just forgot to add that chart in. Okay, so driving performance requirements from simulation. Again, this is really a key capability of Innoslate and Sopatra. So Sopatra is a simplified version of Innoslate to a great extent. It has a little bit different user interface. It's focused on analyzing, creating and analyzing standard operating procedures. The way Sopatra works is, particularly if you already have a written procedure, you can ingest that written procedure. It'll create an initial action diagram for you from the natural language text of the procedure. And then from that, you can do your analysis, and particularly setting up timing. And so the Monte Carlo output of Innoslate has been modified in Sopatra to deal with specific metrics, very key metrics to help you understand. And one is TOP, which is the time of procedure. How long does it take me to run the procedure? AOTW is my available operational time window. That is the amount of time I have to act before something bad happens. Okay, and you can think of all the bad things that can happen in a process, right? And so then we compare those two, and then from that derive PBT, the procedure buffer time. How much time do I have in excess, hopefully, to that I mitigate my risk? Again, this is also kind of getting to risk a little bit and risk analysis as you're doing these Monte Carlos. Now, of course, the way we get these distributions is we're adding time distributions to each of the variables that are appropriate in the action diagram. And so that's where those come from. And with Sopatra, there's actually a database that's available from some research done by George Mason University. And they have done a decade or so of research in this area. And so they were derived a set of very, very useful time distributions. So I think you'll find that that's a very nice aid as you're trying to do this kind of work. Okay, so process modeling. So again, process modeling can include test processes. So again, as you're going through and you're developing your overall system architecture, so yeah, everybody says, well, is this really part of the requirements? Yeah, I mean, I have to test it. So I have got to create my verification requirements, I have to be able to deal with those. I have to create my plans and all the other things. That's all part of this process. So we want to think about those and start developing them as we go. You can also use our test center to take a look at your expected result, your actual result status for each test case, and then again link those back to the requirements. So then you have that traceability with it as well, which again, I'm about to slide ahead again. Anyway, so hopefully that helps you see those. And of course, those expected results often are your metrics that you're looking at. And so you might have captured those as measures. So you might want to trace those to that. Again, so a lot of ways to use the tool to curate the information and work with it. Traceability. So again, we have a spider diagram as the primary traceability diagram in lifecycle modeling language. And so we apply that. As you can see, this gets to be pretty big. And so the key is that you want to link the requirements to each other all the way through the path. So maybe I link a requirement to an action. That's my functional analysis. So I'm going to tie a requirement to the action and derive lower level functional requirements. So that's one step of that. And then, or maybe it's a performance requirement. So I'm going to allocate it directly to a component of the system, which we call assets. So that's me. Or I'm going to tie it to measures. So these are things you might see in something like this. Now, a lot of people think of traceability as just requirements traceability. We actually look at traceability between all the different information in the database, because the requirements, just the requirements, are insufficient. I need to track my risks. You can do issue tracking as well. You can tie it with cost. This might have great cost implications you want to track, or schedule implications. You tie it to your milestones. There's so many things that come together with that trade. And a lot of people also say, well, what about change? What if I change something? Well, basically, in reality, if you change a requirement, then you got to look at downstream at all the things it touches, because it can affect any of those. And now we do help you a little bit with that. At least one level down is the traceability matrix. So the traceability matrix can show you how you've connected things together. And then we have traceability assist and suspect assist. The traceability assist is the green boxes, and the darker the green, the more chance the NLP algorithm says those should be connected to each other. So as you can see, you can start seeing where now, and of course it's opposite for the suspect assist, right? And so you can start seeing where maybe you have some disconnects in the requirement. So you can use that to help you identify change and see what the impact of that change is. And then you can flow it down through the process. So through the spider diagram. So nothing prevents you, by the way, since this is a browser-based tool, you can have multiple tabs up with the same project. And so you can see different views of it that way. And I find myself doing that a lot because there's so many pieces of information I'm trying to look at. I often want to look at 2 or 3 at the same time. So I might have multiple tabs. I might pull them into different windows on different screens. So it really does let you look at all the problem and work with all the problems go. I mentioned Sopatra again earlier. Again, that human errors and the human factors is very important to think about, and that's a lot of what we do. One of the things we add automatically in Sopatra for you is these see, hear, and decide actions. So you have an action where you're doing something, and it takes a certain amount of time to do that operation. But oftentimes, it really takes time for an operator to make that decision to do that thing, right? They hear the information or they see something and they've got to react. And that's a different reaction time than the actual time to implement it. And so we separate those out for you automatically and create those for you. And then again, this is a best practice coming from the George Mason research that we've implemented. So I think, again, this will really help you do a better job of modeling your standard operating procedures. So creating verification requirements, actually very, very important. That part of it's also available in Innoslate. Again, you could create separate documents for that purpose. Currently, we use labels for this to determine the different methods for verification. So these are the 5 we have: analysis, demonstration, inspection, modeling, simulation, and test. You can certainly add to that list if you need to, and use those to help you filter. Our VCRM actually uses those labels and will show those as part of the requirements matrix that you can create for that verification matrix. Also notice, by the way, the indicators, I forgot probably earlier to show you the indicators to show those traceability relationships have been established. So the S is satisfied by, the T is traced to, and the V is verified by. So those are the primary traceability relationships that people use, and so you can apply those as is appropriate for your approach. And so generating that VCRM, the verification cross-reference matrix, again, is very easy. It's a simple report that's available in that view. Then this shows you an output of it. On the bottom right, it goes to Excel. And in Excel, we can colorize the cells which are blank and highlight them for you in red, so you can say, oh, okay, we haven't selected a verification method yet. So it just helps you with completeness with that. Yeah, obviously, with something this small, it's not a big deal, but you start getting 100 lines, 1,000 lines spreadsheet, the red lines will help you a lot in finding holes. An alternative method that's being proposed, and something very interesting, is the idea of having a separate subclass of statement called verification requirement. The attributes of that have been proposed are a verification method, acceptance criteria, evidence, and rationale. Notice that the quality factors that we have for requirements are not here. That's okay. A lot of people think that those don't really apply to a verification requirement. So if you feel it doesn't apply, then do this. If you feel like it does apply, then just simply subclass the requirement and add these other factors to it, or just add them to the requirements if you think that's appropriate. So you can do that as you need to. So kind of the bottom line is try to be a requirements hero. We hear about the effect of bad requirements all the time. It usually ends up being a very tragic news story. I think a lot of people remember the BP oil spill. That directly can be traced back to some requirements that were missing, and other problems. And people skipping with the steps, which was again part of that whole quality thing you try to do. But many other things can be traced back directly to requirements or just poor procedures, standard operating procedures. So again, this is something you can do to make sure that things are correct and are working well, and that particularly for life critical things, we don't have that kind of a problem. Anyway, so again, if you can develop high quality requirements using Innoslate as quality checker in our intelligence view. And again, I think you can reduce all kinds of errors, not just medical staff errors, but all kinds of errors by using Sopatra. So I don't have time, I guess, to demo. I want to make sure I leave a little bit of time for Q&A. So are there questions, Elizabeth?
We have a few questions so far. If you haven't done so, please use the panel on the right to ask us your questions. So our first question is, regarding the schema you presented a moment ago, does each domain have its own schema, maritime intelligence, UAV, etc.?
What we find is we extend the schema project by project and usually add specific terms and things for different domains. Oftentimes, what I find most of the time I add is labels, because oftentimes what we realize is that the objects are like, it's like an asset. Do I need the asset to have a lot of attributes associated with it? If I don't, then maybe I don't subclass that. maybe I just add a label for it. So things like that. So it just depends on what you're trying to get done and what information you're trying to gather and capture, because you can capture things in as characteristics, for example. And we use characteristics as like a floating attribute. So for example, if I want to put a color to assets, I don't have to, I could have like, we work with the Navy a lot, so we like to say we paint everything gray. We don't paint everything gray, right? We don't paint people gray. we don't paint everything inside the ship gray necessarily. But we paint the outside gray because that's historically works well with avoiding fog. So you might have that as a characteristic that then is applied to the assets that are appropriate to put it on. So those are the kinds of ways we do that. But yeah, if you need to extend the schema, that's what it's there for.
Our next question is, can you link to / get requirements from rationale doors?
Yeah, so actually we have RecIf import-export capabilities, so you can use that as a mechanism. There's also a good CSV import-export, which can do that too if you're not used to RecIf. I highly recommend RecIf as the more standard approach to doing that. Also with the Doors Next Gen, it is a cloud-based tool, and so you can create hyperlinks in between the two very easily. And I've done that in the past, so if you need to. I will say though, we recommend moving the material out of Doors as much as possible so you can do the analytics that we provide within Innoslate. It's a lot harder to do that. And then maybe if you need to move it back for curation or something else you're doing, that's fine.
Our next question is, Innoslate functional analysis equal functional flow block diagram?
It's very similar. The FFBD, particularly out of the tools I used it in was RDD 100 and Core, and I believe Genesis also uses that approach. And I think there's something similar in Cradle. Again, yeah, it's just a different. We call it an action diagram, and what makes it different is that we don't have constructs. We have a special type of actions for decision points. Because what helps you with that is that the actions then are allocatable, and which is what you want to do. You want that to be a functional requirement of the decision of who or what makes the decision. And so we found that for a couple that actually makes it more understandable and makes it clearer, but also gives you that extra dimension of capturing the decisions as functional requirements as well. It kind of forces you to think of them that way.
Thanks, Dr. Dam. So we don't have actually any more questions right now. Let's give everyone maybe a few more minutes to send in their questions. Why don't we take that time and do the demonstration portion since we still have 7 minutes?
Okay, sure. I can show a little bit of it. So this is documents view within Innoslate. Let me make this the full screen so we're not seeing all the other junk that's on my screen. and so you have many different documents here available. Again, you can determine which types of documents you're looking for. If I want to see requirements documents only, I just select that to get the requirements documents. I can sort them. I can find them. Again, if you have lots of these documents, I mean, we have databases with hundreds of these documents. You're not going to go scrolling through looking at 15 tiles or whatever, you up to 50 tiles a page. You're not going to do that. You're going to be searching for things, and so we highly recommend using the search feature for that purpose. There is actually a very nice interface with the search, so you can get a very, very definitive search looking for specific things. Okay. So let's take a look at that verification requirements document. So here's an example of a verification requirements document, and this is actually from a book. Applied Space Systems Engineering, so you can see some of these specific requirements from there. Anyway, so these verification requirements have all been looked at and are traced to different things. So if I click on that requirement, again, I can see the labels associated with it. So these are the labels associated with the methods for the most part, and the fact that it's a performance and verification requirement. Okay, so if I want to look at other attributes, they're not on the screen. Those show up on the sidebar. Those give me all my quality factors. So you notice all those look good. All those have been made yes. Relationships. So this is where I can get to the relationships between things. So here's my satisfied by. Remember, I had S, T, and V on that particular one, which is why I picked it. So it's satisfied by. I scroll down, I got trace to, and then I got verified by. And in general, I try to use those. Satisfied by as sort of the system. The trace to is usually a requirement, other requirements, or an action. And then verified by to my test cases. So again, you can set up that as you need to. Also notice there's a comment associated with it. So I can go to the comments tab and see what that comment was. It's been okay. And you can resolve comments and things like that as well. And edit them as you need to for yourself.
We have a question. VR5 is green at 75%. Is that threshold user defined?
No, so the threshold comes from the quality factors that we automatically check. So we check clear, complete, consistent, and design, traceable, and verifiable. The correct and feasible you have to add. They will default to a no, and then they'll have that. But this one actually has two others that are no that were automatic that happened because of the these issues it found, the potential ambiguity and the completeness of it. If I click on one of these other ones, let's see what this looks like. Attributes, yeah. So this is more the typical thing of where everything else looked good, but correct and feasible. I'm sorry, were both defaults to no. So you have to look at it and understand if that's and decide if that's appropriate or not.
What is the threshold for green?
So the threshold for green, I think, is like, let's see, I want to say it's 5 out of 8, or maybe it may be the 6 out of, it may be just this 6 out of 8. I'm trying to remember. Here's 63. Let's take a look at that. I think that's the 5 out of 8. Let's go take a look. Complete, correct, feasible, or all no. So those 3. Yes. So it looks like 75% is just the 6 out of 8, which makes sense. Think about it. Any other questions?
That's all the questions we have.
Okay. Well, why don't we wrap it up here? We got some wrap-up slides for the next thing. Do you want to talk about the next webinar?
Yes, so our next webinar, actually, I want to point out that the date was actually recently changed. It is now March 24th, so the date on these slides is incorrect. We will fix that. The next webinar in our series is how to develop and simulate models with no coding experience. And again, that will be on March 24th at 11 o'clock a.m. Eastern. We'd like to thank you again for joining us today. As a reminder, we will be following up with you soon to send you a link to the recording and the presentation slide deck. Thank you again for your attendance, and we hope to see you again at our next webinar.